Section 2.3, the next part we're going to do slopes and parallel lines. Slopes of lines that are parallel or perpendicular and how to make an equation with that information. So the slopes of parallel lines, looking at this box first, are equal. So notice how these two equations, if I know this equation of the red line, then I can find the equation of the blue line by keeping that same slope, because remember, all I need from this y equals mx plus b, the only information I need to write the equation of a line is the m and the b. So if I already have the m, because I know the two lines are parallel, then all I need is b. So to get the blue line, I keep that same slope. Everything stays the same except that last piece, the intercept changed from +3 to -1. So if I have one line and the fact that it's parallel, then I can find the other line. Similar with perpendicular lines. So I know that y equals mx plus b. If I have two lines that are perpendicular, I know their slopes are opposite reciprocals. So that means change the sign and flip it. So if I have this red line with the slope of m equals, I'm going to do it in red. I have the red line with a slope of -1/2 x. Then to find the slope of the blue line, I would flip it and negate it. So the opposite means take it, instead of a minus, it's a plus. And the reciprocal means instead of 1/2, it's 2/1, which equals +2. So I would write a new line with that slope of 2. This picture happens to have an example where they happen to cross the y-intercept at the same place, but that's not always the case. So let's look at some examples. So these are from your book. I picked out some evens close to your homework set. So I'm going to look at example 4. Okay, so with number 90, for example 4, we want the line that is perpendicular to this line and has this point. So remember, all I ever need to find when I'm looking for the equation of a line is the m and the b. Let's do b in green. I'll put a plus there. So I'm going to start with that equation. So my goal is to find m and b. So I get my b by using the point on the line, and I get the slope by using this equation. That equation's not in slope-intercept form, so it's not immediately obvious what the slope is. So I'm going to put that into slope-intercept form by solving for y. So I want to subtract x from both sides, and I get -y equals 7 minus x, and then I want a positive y, so I'm going to multiply that whole equation by -1, flip everything, so -y becomes positive y, 7 becomes -7, and x becomes positive x. I can see now my slope of this line is going to be 1, because I can see the coefficient of x is 1. That's not obvious. I can also switch around the order and put that term with the x first. So it's x minus 7. But as soon as I get to that form where I have a constant and an x, I can look at the coefficient of x to get my slope. So my slope, and again, this is the perpendicular line. This is not the line I want. But the line that's perpendicular, the slope is 1. My which is as a fraction is the same thing as 1 over 1. So that means the line I want, this one over here, the line I'm looking for is perpendicular to that. So my slope is actually going to be the negative reciprocal of that. So the perpendicular line has a positive slope, so I'm going to have a negative slope. And it's 1 or 1 over 1, and the reciprocal of that is just 1. So my slope is negative 1. Now to find b, I have a couple options. I can always I have a point, so I can take that point and I can plug that point in for the y and the x, because I know this equation will be true for that point. But this point is special because it happens to have a 0 in the x spot, which means that already is my slope, my intercept. So on my graph, that point 0, 6, that already is the y-intercept. So I already have b. b is that 6. If I didn't notice that, then I can always plug it into the equation, and I'd get y equals negative 1 for m, x plus b, and I'm going to plug in that 0, 6, so I get 6 for y, x was 0, and b plus b. And solving for b, this middle term drops out because of the 0, and I get 6 equals b. So now I have all the information I need to write a line. So let's plug in that slope as negative 1, and b is 6 into this, and I get y equals, I'll plug in the slope and the b. The slope is negative 1. The b is, the intercept is 6. And simplifying that, I don't have to write 1 as a coefficient, so I'll just write y equals negative x plus 6. So that's a final slope-intercept form answer. I also just wanted to make a side note that this could also switch around as long as I keep the signs together. So I could write the intercept first and the slope second, as long as I keep the right sign. So those are equivalent equations, and they're in slope-intercept form. So either of those answers are correct, and they say the same thing. All right, let's try another example. This time I'm perpendicular to the x-axis. Okay, so the x-axis is this line right here. That means the slope equals 0. So I now, and I'm perpendicular to it, so the negative reciprocal of 0 is undefined. So if I have 0 over 1, that's the way to write 0 as a fraction. If I try to take the negative reciprocal of that, I get, that's the perpendicular line. So my slope would be the negative 1 over 0, and that is undefined, right? You can't have 0 in the denominator. So this slope is undefined, and I know it's going to be parallel to that y-axis. So my slope is undefined. M is undefined, and that means my line is actually going to be in the form of x equals something. So wherever the x is, wherever the x crosses the line crosses the x-axis. So I have a point, negative 1, 2 on it. So if x equals negative 1 at any point, and I know the slope is undefined, that means I must have a parallel line at, vertical line at x equals negative 1. So when slope is undefined, when you have vertical lines, that means you can't really do the y equals mx plus b form. You have to do x equals whatever that constant is, because it's a straight line. So the y could be anything, but x is always negative 1. So since I know that point negative 1, 2 is there, that means all the other points are negative 1, 3, negative 1, 4, and so on. All the y's are there, but x is always negative 1, so that is my equation. Okay, so in these two examples, in example 4, this b was pretty much given in our point, and in example 5, our slope was given in the fact that it's a vertical line. So let's do one more example where the slope and the intercept take a little more math. Let's do number 98. So remember our y equals mx plus b line. So all we're looking for is the m and the b. So I'm given a line that is perpendicular. So I get the slope from the fact that it's perpendicular to this line, and I'll find the b using the point after I get the slope. So first things first, let's get the slope. So the line, the perpendicular line has the slope of what? I don't know yet because that is not in y equals mx plus b form. So let's convert that so it's easier to read. So I get 6x plus 14y equals 7. I'm going to solve for y to get into y equals mx plus b form. So subtract 6x from both sides, and I get 14y equals 7 minus 6x. And then divide both sides by 14. I get y equals 7 over 14 minus 6 over 14, 6x over 14. Simplifying that, I'm actually going to swap my term with the x in it because I like to have my slope out in front. So I'm going to write that as negative 6 over 14x plus 7 over 14, but I can actually reduce a 7 over 14 to 1 over 2. Oh, yes, and I can reduce, I'm going to reduce things. So that actually reduces to 1 over 2. 6 over 14 reduces to 3 over 7. So I'll write that there too. 3 over 7. So the slope of this perpendicular line is negative 3/7. That's not the slope I'm interested in. The slope I'm interested in is the line that's perpendicular to that. So I'm going to take that perpendicular slope and find, okay, well that means my slope is the opposite reciprocal. So opposite means since it was negative, I'm going to take the positive. And 3/7 becomes 7/3. All right, so that's my slope. I'm going to plug that 7/3 into for m. Now to get b, I don't have the actual intercept from that point. So I'm going to use that point in this equation to find b. So I have the point, I have that m equals 7/3. I'm sorry, that's the wrong color. So my slope is 7/3. And I know that when y equals 3, x equals 6/5 plus, so I just used that point and plugged it into that just so I can find b. Okay, so now I can find b just by solving for b, and I'm going to simplify this as 3 equals, let's see, I can reduce this before I multiply to keep my fractions smaller, so 3 and 6 cancel to 1 and 2. And I get 2 times 7 is 14 over 5 plus b. Then subtracting 14/5 from both sides will give me b. I get b equals, I want 3 minus 14/5. Okay, well, I need a common denominator. So I'm going to change that 3 to get a common denominator of 5, so I'm multiplying by 5 over 5, and I get 15/5 minus 14/5, which gives me b is 1/5. Okay, so now I have my b, and I got my m from up here, and now I can rewrite that generic equation with y and x being written as variables again, and plug in. My m is a positive 7/3, and my b is 1/5. And there's my final answer.